Hey everyone, this is Mikhail from OpsMill, and we will be talking about taming your infrastructure data silos. And I'm accompanied by Alex. Um, Alex, do you want to go ahead and introduce yourself?
Yeah, Alex Gittings, solution architect here at OpsMill, working with customers to deploy Infrahub and OpsMill related technologies and yeah, work with the open source community.
Awesome. So yeah, we're here to talk to you about having all the different data silos and some of the problems that come along with this. So if we take a look at this, we typically have many different sources of information in an organization. Um, it's typically pretty complex, right? Systems may have overlapping data, or just different data in different sources. And then how do different people, have their different use cases, whether it's reporting, configuring the network? How does that all end up coming together for those different use cases? Um, there's typically, due to it being fragmented, there's the complexity that comes along with that, and some of the challenges that kind of arise from having this issue within organizations, is that the data can live in different places. So when it data does live in different tools, we often question kind of where, which source is authoritative, because typically, like if we look at Cloud Vision or IP Fabric, ServiceNow, they all have pieces of the same information, but we're not sure which one is authoritative. So that typically runs into a lot of issues that we'll cover. Another issue is really how does that information get updated and who owns it? So typically a team will own info blocks, but when does that get updated? It's typically a manual process. So we have challenges there. Um, Also, the other issue is with all these disparate, pieces of data, when we have different use cases, right? We may have a business intelligence team that is doing more reporting on the network or assets within the network. We could have a network engineer, right, is going to be configuring devices and they need to aggregate that data somehow. And then also with the network operations is like which devices do we monitor and how do we alert and figure out what is important. Um, Typically, that requires each of those people to end up aggregating the data from the different systems. And then, really, what it looks like is a different piece of the puzzle for each of them. And then we get the logic that is kind of all over the place and not centralized. So if a piece of data does change or a process changes, like a name, like naming standards, each person has to update their automation or their process to actually make sure that data is accurate. So that is some of the issues that we, run into with having, just complex data within an organization. So how do we wrangle them together? Some of the, costs of these, issues that we face with having the data everywhere. Whoops is it really ends up slowing down operations and deployments. So some examples of that is that we mentioned earlier was manual updates. Who updates it? When does it get updated? And does it get updated in all the systems? Probably not. This could also affect the speed of resolving issues, right? If people aren't sure where to get information, or what the network should look like whenever it's not working as expected. It typically takes a lot of time to look in this system, look in this system, and then actually, correlate all the data and determine the issue. When your data is also, separated and stuff, and that logic is in different places, those scripts end up becoming very fragile, which can cause a lot of other issues. Typically, with the business impact is, slower time to resolution. you end up getting different risk with, maybe security. Maybe there's a device that is on the network, but it's not really being utilized, but it is a jump point for someone. And then there's also just business intelligence. If you're looking to make business decisions based on maybe how many circuits we have, how much they cost, and just truing up some of that, right? To make sure we're not overrunning costs or spending money on things that we shouldn't be at this point. Those are some of the costs that we get with having this fragmented data in different systems.
So what we typically see is when we're doing a lot of network automation projects is there's some scenarios where the data inconsistency can break network automation. And this could be a manner of different things. We've put a few down here, but specifically in network operations, they might want the devices to be automatically added to the tools that they use. They might not be provisioning devices, they might be looking after them. And the handover period between teams, if the process is not rigorous enough, you can miss tools from devices if it's manually updated. So here's where inconsistent data might break that, is that you might want tooling to be automatically updated when it's handed over between teams. For example, on the monitoring side, if you have a security department looking at different security vulnerabilities, we might want to make sure that the network is compliant so that tools are automatically scanned for different vulnerabilities, making sure the software version's okay, and many other tools, logging, TACACS verification, making sure that the devices have been added to different TACACS and network policy systems so people can access them and policies are applied across the network consistently. If there's different data in different platforms, it also means that configuration might be harder to achieve. That configuration you push to devices, although we're getting there on some network vendors, ultimately we do have to build a configuration in some instance, but that data might need to come from many different platforms. And if you don't have that data available, it might lead to provisioning errors or inconsistency when we come to deploy the network. And another key part of network automation is specifically business intelligence. We want to make sure that services are deployed to the network consistently, but the way that a business might manage those business intelligence rules, the policies that might apply to interfaces, might be on a different tool. If you're a service provider, you might have a provisioning system that looks after customer information. And if that's not part of the deployment tool, then there might be a data inconsistency there that might affect customers. Um, so we see that out in the real world quite commonly. So if we could go to the next slide, there we go, traditional data federation and where it falls short. So traditionally, people are syncing data manually, making sure that we're relying on manual processes to update data. It might be part of a Word document, a PDF, a worksheet. That once you've done X, go and update the platform to make sure that the data's been added. And now we all know people miss or misread the line, they skip the line, they become too comfortable, so they don't look at the documentation. It might be updated and skip those manual processes. There might be different parts of the businesses doing different synchronization tasks. Maybe a part of the organization is only interested in a certain part of data, part of some data, so they only synchronize from ServiceNow to another tool, for example, and they don't do two-way synchronization and things like that. Another instance we've seen is who owns the data, who tracks it, who owns it. We call that data lineage. So one, who owns the data and where did it come from? But more importantly, what's the authoritative source? Do we update it on one system and that is federated to another system? Or do we uh, update it in one place and it gets updated? basically who has ownership of that data and where does it get updated. So if it's a business rule, it might be in the business tracking software that tracks services, um, and the networking team might not have access to their data. So the authoritative source might be that services platform. But you might need access to that information to be able to derive configuration in the network.
All right. Yeah, so if we've defined the problem, right, and some of the downsides to this, from our perspective, and this is going to look different for a lot of different organizations, such as Alex mentioned, there's, business processes, who owns it, and all that stuff. But what we're really looking at is an intelligent data federation. This is basically in an automated fashion, right? You want to have those business rules stored in more of a centralized process or place that then pulls in and federates the data from the different sources. So that is very important. Typically, you do want a flexible schema as well. As businesses evolve, problems evolve, having the data model that allows the evolution of that data in business is very important. Um, Alex just touched on data lineage. It's very important to kind of know if you see in the image there, we can see what the source is. There's no owner, but that can be defined. And then we also understand when it was updated, right? So this is typically a continuous process. So understanding when that data changed is very important. To really understanding the behavior of the network as well when you get to the point of actually using this federation to push changes to the network. Another important thing to have is idempotent synchronization. This basically means that we can run this synchronization from the different sources and trust that it's going to be the same every time. So we don't want any different behavior that can negatively impact this because the once you federate it, that data becomes very important. Another important thing is to, you're going to have different sources. You don't need to duplicate all the data. You're going to have little pieces that matter, but the value you get from basically duplicating each source into your data federation tool or product is probably not going to be the most effective, and then it's going to really be data overload. So it's really important to understand the context of why you're building the data federation. Um, so you properly solve the issue and don't cause, unintended consequences of having, multiple pieces of data. Along with that is that process really helps you understand which system should be authoritative for the different pieces of information. If we're talking about circuits, it could be, peering manager, can be a component of it. And we only want to synchronize in some of that information, not everything it has.
Yes, so kind of got this icon here to demonstrate some of the intent federations. So in one platform, for example, Infrahub, we can pull the data from all of these different tools so that we have it available when doing things like generating configuration or using it to using generators to build new uh, assets within the organization in the networking world or the cloud world. And all this information can be pulled in and make sure it's appropriately tagged with the correct owner and lineage so that we know where to go and query the information and know where it lives. And then we can then use that intelligently to build an intent. So the intent might be spread out across the network where we can kind of aggregate it into one place, but still maintaining that you do have different tools for different purposes. We just aggregate it and make sure the federation is correct, and then we can push that intent towards the network. So it's important that we're not trying to get rid of tools here, we're trying to make it more efficient and track that lineage of the data.
Yes, and then basically that allows, one of the problems is that business logic is duplicated everywhere. This should alleviate a lot of it when it comes to actually gathering the data that they need. So it's very important, right? We have two use cases depicted here, and they both hit the same point to get the data they need, rather than going to each system again and then doing their own logic, at least for coordinating the data together. The important thing as well is, networks and all this is the value is not just having the data necessarily. It's really kind of understanding the relationships and how everything relates together. So whenever you start off and you have all the different places you could get data, they're basically just individual data sets, right? They provide great context in one matter, but they don't holistically show what maybe a device or a part of the network really is. Um, so what we end up doing is having those individual data sets, and then we create a schema, and those kind of tie everything together and provide that, I guess, safety in a way. We know how it should be modeled. We know how to access the data. It's consistent. And then as we move along, we're going to actually start to put the relationships together. So the typical ones, I guess, is like interfaces to devices and all that. But the important part is, with the flexible schema, you get to actually define maybe more business context around that data or model a service which depicts, is tied to a customer, and then they are part of this VPC or this VPN and all that. So really the value is that those relationships, that are meaningful to the business. It's not just getting, something in JSON and then being able to do something with it. It's really understanding how the data correlates to each other.
So what scenarios do we see in the real world for this? Um, we've come across a lot in our time at OpsMill and over the years, but a lot of brownfield data federation is going on, and that's typically because organizations want to have a more declarative approach on their network and want to start using automation to deliver configuration. So we see a lot of tools like Slurp'it coming in, and that what they do is go and query the network, show you what the live network looks like, and we can use that data to then sync into our tool so that we have either the information available and can start manipulating it to derive intent. We might also have different information, as we've mentioned previously, in different CMDBs, IPAM solutions. They might be ticketing tools, for example, that we might need to pull information in. That might be things like configuration item information from a CMDB, like the asset number. We might not be really interested in that within Infrahub, but we might need that information in in Infrahub that's federated and make sure that it has the correct lineage. So if some automation tool needs it, we can go and track where that information does belong and where the authoritative source lives. Real-time updates, we see some real world scenarios where networking information can go and like syslogs or webhooks from other platforms or message bus information might need to be ingested into a tool like Infrahub uh, in a more real-time manner. For example, the status of a device um, and other information like that.
Yes, and then so with Infrahub, we gain, the data lineage that we showed earlier. So we build in some of this stuff into the platform, and then we also have some tools to accompany, right, to get you to the point where you could synchronize the data and stuff. One of our solutions is Infrahub Sync. It's a tool that has sources. So we support NetBox, Slurp'it, IP Fabric, Peering Manager, and a few others. Um, but what we're able to do, or what interface we kind of provide, is we try and make it easy for you. So it uses diffsync under the hood, and that is an open source library that will take data from a source, destination, compare them, and then only synchronize the data that has changed. And that's all done via a configuration file. So we define a source, destination, the order of the synchronization, and then also a data mapping. So this is aims to really simplify the synchronization process for organizations that have all those different data sources. We will be showing a demo, which we're basically going to hop into. But this one is synchronizing NetBox to Infrahub. NetBox can manage a bunch of different things, DCIM, IPAM, circuits, and all that. So typically that may have some of the information, but not be completely modeled. And then we're gonna end up using that to synchronize into Infrahub, where we may be, with the flexible schema, we can augment it further, modeling, BGP peering, maybe the business logic as well, right? A customer service for an ISP or customers connecting to it. So we'll go into that now. I am gonna stop sharing real fast, just to get the demo stuff set up. And then we'll kind of just walk through the actual um, case for that. And then we'll walk through a few different, let me see where that
Feel free
is.
to ask any questions in the Q&A if you have any questions around Infrahub Sync or how Infrahub works. Yeah, so Infrahub Sync is really a tool to manage the simplicity of just defining a configuration file of what syncs where, and then it will manage the things under the hood, all the adapters and supported tools.
Yep, exactly. So for this example, we've just spun up a NetBox instance with some data that they provide to kind of bootstrap an instance.
Could you
Um,
zoom in a bit, Mikhail?
yeah,
And on the
sorry.
code screen as well.
Is that good or do we need more?
One more should do it.
Okay, cool.
There we go.
Yeah, this just has, devices and stuff. It's going to be a overall pretty rudimentary example. So we have our NetBox instance with some devices. We're not going to synchronize all the devices. We are going to skip some that like PDUs um, and patch panels. We also have a InfraHub instance spun up that is just really blank at this point, right? So it's more of the just getting the data that exists in other places into Infrahub using Infrahub Sync. So if we start off here, we start off with the config.yaml file. That's what we showed on the previous screen, but it basically provides a definition, right? So we define the source, which is going to be NetBox. These are available via, other config options, but we're basically connecting to our instance of NetBox with the token, and then our destination is Infrahub. Typically, with a lot of these things, they're stored in a database. So order does typically matter. You just can't throw data at it. So we do offer the ability to define the order. Some of the common examples is you probably need a device, and then your interfaces. So this basically defines the order of how it will be synchronized between the two systems. We do have the schema mapping. This takes the name of the Infrahub model, which we've loaded. We have a schema for NetBox defined for Infrahub. So this is a built-in, but it basically does the mapping from this is our Infrahub model or schema, and then this is the mapping to the source side. So in this case, it's going to be NetBox, so extras.tags. And then we also do the field mapping. So not only just the actual schema nodes, but the fields as well. Um, some of these are more generic, but if we find some of the more complex ones, we offer different things. We offer filters and transforms for the schema model. Um, Let me find, yeah, this one. So for our device, we have a lot of these different fields. But what we're wanting to do is filter. So we want to make sure the devices that are coming from NetBox, they're not empty. And then this is where we're doing some of that filtering, right? Today we don't want to sync in PDUs and patch panels. Those don't provide the context we need at this point. So we are filtering them out. But we also offer transforms as well. So you could transform the data using Jinja from the source system to what we want in our destination system of Infrahub. Um, so with all these mappings, we basically get to define the logic to translate between one system to the other. With this, once this is all defined, we run the basically we Infrahub Sync will take this and then build out the underlying diff sync adapters. So if we take a look at these, we'll start at the source system. Um, this is basically diff sync. So we take care of it for you based off that config. And this is basically just telling it what there is to synchronize. And then we go into our models, and then this more or less relates to, okay, what are the fields that we have defined for those schema nodes? Um, and then whether they're required and the model names and stuff like this. So basically we abstracted it away into a config to automatically build these for you. So it should make really the synchronization process a lot more straightforward um, for when you're trying to federate the data. And then what we want to do after we have these generated, we're basically ready to do the synchronization. We offer a diff command. This is all, Infrahub Sync is the CLI tool um, command that you're going to use. The generate did end up basically generating those models for us in the adapters. And then we just gave it the directory and all that to sync from. So we're going to reuse this config file in this directory, but we're actually going to do the diffs. So this will basically show us what the difference is between the two systems. Today it's an empty system, so pretty much everything's going to be missing. But we do offer, showing what will actually be synchronized. And then you can see that they're missing. So now that we know that there is a lot, to synchronize, we'll end up using that. We've used the generate command, the diff command, and then we will use the sync command. And then
Yeah,
this
and the sync will apply the the changes, I guess, Mikhail.
Yes, that is correct. So basically, we were able to see what it would do, and then this synchronization process actually moves the data from one source to the other, or I guess copies it really. So we're taking the data from NetBox, and then we're putting it into Infrahub. So it'll
Nice.
kind of work along, and then we should see once this is done, it's gonna do a lot of the different models, right? If we have see this, it's gonna basically synchronize all these different things.
Yeah.
So, um, can take a little bit of time just due to the amount of data that is in there. Um, and we're just showing the progress. I'm not sure if there's any questions at this point. Yeah, it doesn't look like it. So yeah, we'll wait for this process to complete, and then we should be able to see our devices
Nice.
across the two systems. So we're able to refresh, make this larger since we've kind of done the coding part of it for this. But we can see that we've synchronized 31 devices over. We were able to synchronize their location, the model, the rack, their role, and organization. So we were able to actually get a lot of that information and context there. Um, and then we can look at VLANs as well. So it's all synchronized over. But again, as you can see with this was all these relationships are important, right? And we were able to bring those over to from NetBox into Infrahub.
Awesome. And does the Infrahub Sync, is it branch aware?
It can be branch aware, yes. So you could define a branch, which typically what we could do is sync it into a branch and view the diff so then we can actually see what will change.
Hmm.
And then have approval processes for it. So if the synchronized data doesn't look clean for some reason or whatever data integrity issues we may have there, that can be handled within like a branch and then a proposed change to show it.
Awesome.
But we do have that
Yeah.
flexibility. And then that is the demo for
Does
this.
anyone have any questions? Feel free to put them in the Q&A, and we'd be happy to open it up. We do have a last slide to kind of show you um, if there is some prompting questions, but hopefully we can have a look. So where can you start? Head to docs.infrahub.app, and there'll be a tab on the top of the screen, and it's called integrations. Select that and head to Infrahub Sync, and all the information around Infrahub Sync will be there about how to do that. Infrahub Sync is general purpose. It's not to sync information to uh, Infrahub. It's a general synchronization tool. It's a tool to synchronize between platforms, not just to Infrahub. So if the adapters support it, we can also push to other tools as well, like Peering Manager. But it does require the adapters to support that. Um, I've put, do we support X, Y, or Z? Currently, we support a lot of a few of the common ones we've come across. So pulling information from IP Fabric, we can do that. Pulling information from different tables. Libra NMS, we can pull some information from Libra NMS to Infrahub. Nautobot, we have the same kind of situation there, similar to NetBox that we just showed. Obviously, NetBox that we've just showed as well. Observium, we can do peering manager, we can do a two-way synchronization with, and also Slurp'it. So we support the two data kind of network discovery tools. We support some current uh, um, uh, infrastructure tools and some management tools like Observium and Libre NMS. And they're the ones, if there's anything missing, feel free to like hit us up. You can scan that QR code there and that'll drop us in our Discord community. server where you'll be able to ask questions about synchronization. Um, and yeah, our most popular adapters at the moment are definitely Slurp'it and definitely NetBox at the moment. I think they're two common ones that we work a lot with, and our customers are using, and the community members are using to synchronize information between platforms. So I see no questions have come in. Anything you want to add, Mikhail?
Um, Maybe on the where do I start? Sometimes, yeah, when you're looking at solving the problem, maybe from your perspective, it's always good to kind of just start small. If you're using Ansible today or something and everything's in YAML files, all that really, at least getting data into, Infrahub, and starting to use that as a dynamic inventory, it's a great place to start. You don't have to boil the ocean, and have everything modeled, and ready for config. If you could simply start to, synchronize or get the data from your inventory host vars, into it and use that external system such as Infrahub, that's typically a good place to start. And then you could kind of grow your use cases, based on that. And then you could start to look at maybe where other data lives that you're fetching, maybe in your Ansible playbooks or Nornir, tasks. And then start to see, does that require synchronization, and how does that look? I think that's all I would add at this point.
I think another one to add as well is for all the different adapters that we provide a kind of compliant Infrahub schema. Obviously, Infrahub comes without a schema by default, but for all the different synchronization adapters we have a kind of compliant schema to the source that we're coming from. So, for example, there's an Autobot schema, there's an IP fabric schema, there's an Airbox schema that kind of roughly translates between the platforms as well to make it easy to transfer data. One thing to add is that we will be doing a bit of a more of a deep dive within the next month. So keep an eye out for a live stream where myself and Benoit will be going to the more into the more technicals of installing Infrahub Sync and configuring it and doing things that might be a bit more complex than a quick demonstration. Yeah, thank you for your time.